Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. This is Dr. Munder. Today we'll talk about chapter 2 in Object-Oriented Analysis and Design course. And specifically, we'll start talking about UML. I'll give you an introduction about UML. Then we will try to practice some activities in the next lecture, inshallah. So in this lecture, we will have to identify some of the meanings and the use of the UML and what are the benefits and goal of using UML, and also we'll introduce to some of the blocks that used in UML, and also we'll talk about some of the diagrams, number of diagrams that used in UML. Some of them are not in detail, just a quick look at these diagrams because in the next chapter we will practice drawing these diagrams in detail. So when you say UML, we're thinking about building or developing a software. When you try to develop a software, you don't start coding right away because this is not the correct way to build a software anyway. So the correct way to build a software basically is to start by modeling the software, designing the software, understand the requirement of the stakeholders, and then after that you start the implementation. And when we say we have a complex system, we have to say that this system must be understood quite enough in order to implement this system. So we have to model any system before we start somehow implementing the system. And when we say modeling the system, we try to minimize the complexity of the system. Now, in the modeling stage, you try to visualize the system somehow and try to see the design against the user requirement, or what we call it, the stakeholder requirement. Now, object-oriented methodology use unified process, which is developed by the group, object-oriented group. These are an excellent object-oriented methodologies. These are, is not treated as a sequence of steps. Instead, we can say they are help to somehow construct the product in a good way, or in a better way, to increase the efficiency and to reduce the cost of the software. UML is a stand for Unified Modeling Language, which is basically a unified modeling language. When we say language, we are not meaning that it is a programming language. It's just an expression to say that it's a common way to do something. So it's a unified modeling a language to design or visualize the system. Is not a programming language. When you design a system using UML, you can do the implementation in any programming languages that you want. Okay, so basically UML is the main object of using the UML is to visualize and construct and document the software system. So visualize, construct, and document any software system development. Now there's some notation in the UML similar to what we have seen in the other methodologies. They use graphical objects to represent some of the symbols and to do the design and to build the model for any software. Now it was used, as I said before, it was developed or created by the Object-Oriented Management Group. It is not, oh my God, it is Object-Oriented Management Group. Okay? Now, UML, as I said, is not a programming language, but instead, you can depend on the design that produced or developed or modeled by UML to do the implementation in any programming language. So it's just easy for you to convert the UML diagrams and implementation and documentation into an implementation on code using any programming language. Now, if you start the implementation directly, this is not a correct way to build a software. You have to see the main picture of the software, try to fix all the holes in the software, and then after that, you know exactly what is the software is going to do. So basically, you start what? You start building the software and implement it. UML is now become an object management group standards, and everyone using it when developing software. What's the goal of UML? It's a clear picture now. What is the goal of the UML? It is basically a ready-use expression for visualizing what? For visualizing any software before you start what? Before you start modeling it, before you start implementing it. Also, it's a wide extensible and specialization mechanism that you can extend the core concept of the software development, and it is independent of any programming languages. You can do the design and do the programming in any language you want, okay? And also it gives you a basic understanding of the modeling language. Encourage the growth of the object-oriented tool in the market, because object-oriented tools basically is using UML to represent the objects, represent the relationships between object and so on. So if you use UML, you encourage the object-oriented tool in the market. And also it support and encourage collaboration, framework, pattern, and component, which is basically a high level development concept, and can integrate the best practice. And maybe after like a while, years in experience in developing software using UML, you will have, it has become an easy for you, like drinking a cup of coffee or something like that, and you will build the software in just a short time. OML and UML. Now, in object-oriented methodology and in general, when we develop a software, the first thing that we need to do is to identify all the objects in the system. So if you're developing a system for the college, for example, you will say, I have a student object, I have a teacher object, I have a class object, I have a course object, and you try to see, okay, all the objects that could be included inside the system. And when you identify all the objects inside the system, that is easy for you. The second step is to draw a relationship between these objects in order to see the collaboration between each object, and then you refine the diagram, so the implementation will become easy. So basically there are three steps. You have to do the analysis, the design, and the last step is what? The last step is the implementation. As I said, if you know exactly what you're gonna build, then that would be easy for you. It's similar to the building. When you do any building, you have to go to the civil engineering and get some architecture diagram for the building. So when the builder try to do something, he has to follow this diagram and build the diagram exactly as it. And you can see that in front of each building there's a picture showing the building, the model of the building after it's finished, and it will be the same as finished. So the implementation is the easy part, okay? As long as you meet the user requirement, then the implementation will not be easy, the maintenance will be lower, and so on. So as a summary, UML emphasizes the modeling of object-oriented software application, and object-oriented design is transformed into UML diagram, which a number of diagrams that we will look at that satisfy the user requirement in all of them somehow, that cover all the holes and there's no weakness in the system, so the implementation is going to be a short step. Now if you want to know a UML, we have to know the UML blocks, okay? Now we make conceptual model for the system, and then we start gradually adding something until we reach the physical design of the system. Now we have to understand that a few elements before we move to the UML building block. We have to know that there's a UML building block. We have to know there's a rule to connect these blocks together, and we have to follow what? We have to follow a mechanism, a common mechanism, not just any mechanism, a common mechanism that everyone knows that is standard way to do that. So you need to understand these three things or major elements. Now the building blocks, we have three building blocks. We call them things, or sometimes we call them entities, okay? And then we have the relationships, and then we have the diagrams. Now, for the things or the entity, they either structural or behavior. Structural shows the structure of the system, the organization of the system, the hierarchy of the system. Similar when you look at the organization chart for any organization, starting from the boss of the company down to the vice president, down until you reach what? Until you reach the employee. So it is just to show the structure of the organization without caring about the operation. Now, the behavioral system, the behavioral entities or things is about what is the operation inside the system and how we're gonna implement them. And then we have to grouping, which we can group a group of objects together in what we call it sometime package. So we can group them into what we call it, look like this. We call it what? Package. We call it a package, and you can see it in the programming language if you're using Java or C or any object-oriented programming language. And the last one is the annotation. Annotation is more like a note or a comments that could help, in the data. It could be also a condition. So, for example, when we say that the student can register a course, we can put a comment or a condition there that student must be student registered in the college, must be student active in the college, not dismissed, not outside the college, not transferred, and so on. And the relationship, we already have, explained this relationship. We explained the association, we explained the aggregation, we explained the composition, the generalization, specialization, and dependency. And we will have to implement these things in all the diagrams. And the last one is the diagram. We have so many diagrams. Some of the diagram considered structure, some of the diagram considered behavioral, some diagram considered the state diagram, and so on. So these are the three blocks in UML things, or we call it entity, relationship, and diagrams. Now this is a diagram shows exactly these blocks and an example of these blocks. So things, we have structural, behavior, grouping, and there's an example for structural. So we have class, interface, and so on. For behavioral, we have two diagrams. We have interaction and we have state machine. And for the grouping, as I said, we have an example as a package. And for annotation, we have, for example, a node. For the relationship, we have so many relationships: dependency, generalization, association, realization, aggregation, and so on. For diagram, we will use on practice to draw all these diagrams later on in the second part of the chapter, starting from class diagram, object diagram, use case diagram. And I'm sure that if you've done like a capstone project, or in the future if you're working in a programming company or a software development company, you will be able to practice drawing these diagrams a lot. Now, the first one is structured thing. Structured thing is defined the statical part, the fixed part, the things that fixed. So when we say the college has these objects, student, class, teacher, these are of static part. They will not be changed during the system or the running of the system. Now, it could be a physical part, such as student is already exists in the nature. So we have student, we can see the student, we can watch the student, we can touch the student somehow. Some of them are conceptual, such as a process going on in the teaching system, for example. Similar to this one. Now, the structured thing contains a class, and we can implement the class. The class, we said that is just a blueprint for the object. So the class, we can have the name of the class, we can have the attribute that the class contains, we have the operation that the class contains. An interface is somehow is a class, an empty class. For example, we can say shapes. Okay, shapes is a class, for example. Okay, this class is shape, and we can say it is empty. Why it is empty? Because it's responsible about what? About sub classes or child classes. These classes could be a circle, could be a rectangle, could be what? Could be a triangle or any other shape. So this is what? This is an abstract class. It is empty. There's no implementation here. There's no implementation here. All the implementation is here. It's just an interface for all these shapes. All these shapes. And it is more like responsible about these shapes. So if you want to calculate the area of the rectangle, you have to talk to the shapes, and the shapes will get it to you. This is an interface. I'm sure if you've done Java programming or object-oriented Java programming, probably you created an interface and you get override some method and so on. Now the collaboration is more like interaction between elements. If you have an object and this object inside the system, not necessarily an object, any element in the system, and you can define how they collaborate with each other by calling each other methods or by passing a message between them. Use case is an operation that performed by the system, and it could be drawn in an oval, and we will build a use case diagram. We'll see some of the sample later on. Component is describe the physical part of the system before running the system. This is the physical part, will be always in the system, okay? It is called the component. It's the physical part of the system. But when we say node define the element that exists, or the physical element that exists after we run, or at the runtime. Before the runtime, it will not exist, and after the run ended, maybe some of them will stay. But I mean, just a node define a physical element that exists after the run. So component is defined, and a physical object in the system exists before the run and will exist after the run. But for the node, it's defined the physical element that exists at the runtime only. Behavioral things, it is not static, it is more like dynamic things. It's an operation, okay? For example, we have the interactions such as what? Such as passing a message between two objects, so they interact with each other. So if object 1 is sending a message to object 2, that means their interaction between them, okay? So the interaction could be by sending a message or calling a method in that object or class which represent the object. State machine diagram is define the state of the system. It care about the state of the object. So for example, we have the traffic light. We have 3 states for the traffic light. We have the red and the green and the yellow. So it keeps the state sequence of the state or change of the state of an object through executing some events or running some function and so on. So it is called the state machine, and it is the notation for it. It looks like this. This is mean what? This mean a state of the object. Grouping and annotation. Grouping is putting similar classes or objects in one package, and it's a good idea because sometimes you may need to reuse these classes or reuse the whole package. Annotation is more like a comment which include the general comment, a guidelines, a condition, a constraint, and so on that you can put in the diagram. It's not an operation, it's not a structure in the system, it's not even necessary, but it is somehow a guidance for the developer. Relationship, we study more than which we have a normal relationship, which is basically a link between two objects, okay? And this means that there's a collaboration or there's a relationship between two objects. So if there's a link between object A and object B, it means what? It means there's a relationship between them. And all other relationships Types are considered association. Dependency, no. Dependency, that means what? That means if you have an object A, depends, and this is how we draw it, depend on object A. That means if the state of A change, this will affect what? This will affect B. Okay, similar to the traffic light, if the state of the traffic light change from green to stop, this will affect the state of the car from moving to stop. So there's a dependency between the car and the traffic light. They depend on each other somehow. If someone change the state, it will affect what? It will affect the other object state. Generalization is more like what? A general things like shapes. So the general way, when you look at I ask you, I draw a circle and rectangle or triangle, and say, what is this? You say it's a shape. Okay, so you said the general name. Okay, but if you want to go more specialization, you could say it's a rectangle or triangle or circle. Similar to say, what is your major? You say my major is IT. So this is the generalization, but basically you are what? You are in the security. Okay, your major is security. Okay, your major is security, and also it's not security, it is somehow forensics. It is forensics. Okay, so when we said the generalization, this is a simple. The generalization is a form of inheritance. So you have child, and the child inherit everything from the parent, and the parent could be an interface that's responsible about these objects or these classes. When we say realization, we mean there is two element. What? There's two element connected to each other, and one of them is responsible about the other one. So this is used exactly in the interface when there is a responsibility for a class to other classes. This table is taken from the book reference. It shows all the samples with examples, and you can see this is an example. Don't worry right now, you will practice these examples later on, but I suggest you have a look at them, get more understanding about them. These are also the relationship, and we add to them the aggregation in two forms, the composition and the normal aggregation. Now, UML diagram, we have so many diagrams. Now, we split the diagram into two types, behavioral and structural. Structural will describe the structure of the system or the organization of the system, such as the class diagram, such as object diagram, component diagram. They all describe the structure of the system. They are not describing the operation, they are not describing the flow of the data and so on. It's only their focus is on the structure of the system. And the behavioral diagram describe how the operation is going on inside the system, such as interaction diagram, such as the sequence diagram, such as sequence diagram. And this diagram shows the object, the data flow from one object to another, what's the responsibility of this object, what's the operation has been done on this object, what's the input and output of this operation, and so on. Now let's take an example. Okay, for example, we have the class diagram. The class diagram, okay, is a very simple diagram that shows a link between all the objects in the system. So when we say the class is a blueprint for the. So we have, for example, here four objects or four classes. We have the order, we have the customer, the stock, and the product. And we have for each one, we have the attribute or information that can be saved for it. For example, the customer, we have customer ID, customer name, address, and phone. And these are the operation or the behavior for this class or this object. So we can have add customer, edit customer, and delete customer. Same thing for other objects. They have attributes, and they have what? And they have behavior as well. And now you can look at the link between these classes. There's something in the link. For example, here is each customer is order at least one. So we have here at least one order, at least one order or more. That means one plus. That means one order at least, or it cannot be zero order. But the order can be ordered by no customer. That means there is no order. And as you can see that there's the order is conclude a product, and the product is part of the order. So this is the order. The order contain a product as part of it, and then you can see the aggregation is normal aggregation because we can split the product from the order, and the same relationship between product and the stock is a normal aggregation. Another case, another diagram is called the use case diagram. This use case diagram shows the operation of the system and who can do this operation from the user and who cannot do this. For example, we have a simple case diagram. We have three operations. We have sell, we have close shop, we have add a new product. So we can say that the salesman can sell and can what? Can close the shop. And the store manager, whatever is it, can add a new item or can close the shop. But the customer can do only one operation, can do only sell operation. So these are our operation, and we call this what? A use case diagram, and we will learn how to draw the use case diagram inshallah. Now the second diagram is called the sequence diagram. The sequence diagram is a behavioral diagram that actually capture the event or show the event and how the event performed and which objects are involved in the event. So for example, in this diagram we have a sequence diagram for check mail operation, and we have two objects involved. This is the computer, one of them, and we have the server, the second object. And we can see when the computer is involved and when the server is not involved. You can see that the computer or the user computer is involved all the time. It will send an unsent email to the server, so the server can send them. And also we'll have create a new mail, and the server can respond with success or not success, sent or not sent, and so on. Also the computer, if you want to check the email, will have to download the email or delete all email. As you can see that the server is work on some time, it's not active all the time. So you can see there's a function will be executed, and you can see the message over the relationship between this object. Okay, it might be not as you expect, but it's just a snapshot about the sequence diagram. Last one is data model. Data model is about the data. It care about the data. Where does it go? What happened? It is input for which process? It's output from which process? And will stored be in the database or sent back to the customer, and so on. And we also, there's so many annotation, but we will focus on this notation. It's very simple and easy in the next chapter inshallah. Now this is enough as an introduction. So what's the benefit of the ML? ML, you can professionally design and document software system for implementation. If you want to be, your software is robust and much better and last for sometimes, not disappear in a while, you have to professionally design and document your system before you start the coding, because coding is not a problem now. Also, if you do that, you will have a low cost. Low cost in terms of the code can be reusable in the same project or in other projects, such as the student class. It is if you develop a system for every college, and then you can develop another system for Bridge College, for example, because the same class is there, student and student. So reuse the code, okay? Which will give you high efficiency as well, because you are sure. Now, when you do the design, you try to minimize the weakness and the holes in the system that can be captured in the design stage. And also you will build and somehow try to see all the operation and all the output expected from the system. Also, the overall system design will be dictate the way that the software developed, of course, because you design it as the user requirement. Okay, so you have to make the right decision before start coding, because it's not a good idea to start coding directly. We have three options. So you could have start. You have the code. Okay, code, and let me just erase that, and I can explain that to you. So we have the code, and we have the design. I'm just gonna write the first three letters. Okay, design. These two operations. You could start code and design together until you finish the system, or you could what? Or you could start the design first, finish the design, and then after that you can what? You can start the code until you finish the system. Or you could what? You could start the design here, and in some stages you can start in parallel the design, but you have to make the design go ahead a little bit so you know exactly what to do. If you are more professional, you could go with the first one, because you have a lot of years in experience developing software, and it's going to be easy for you to do that, because you use some of the code or some of the design for a previous system. But if you have less experience, you could use this approach, and which is the best approach: design first, and then after that start the coding. Or if you have a little bit more experience and you are more confident, you could go design first, and then after some while you start the coding and you go in parallel. It depends on how you do, but the best approach is to design first and then implement, do the implementation after that. If you do that, you will reduce the cost, you will have low maintenance to the system, because you plan the system for some time in the future, and also your system will be more efficient system than others. You could discuss with your friends why do we need to do the design before we start the implementation, and try to see which approach is suitable for you in order to complete. This is just a discussion for you. As a summary, we have described what is the ML. When we said it's a standard way to model any software system when you develop it before the implementation. And then we also discussed the main goal and the main benefit of the UML. And we said that the UML emphasizes on modeling object-oriented software application. And we discussed three things that we need to understand in UML, and we explained three blocks in UML. So we have the entities, or the block, the relationship between these blocks, and this relationship should be according to a common and standard mechanism. And the blocks are things or elements, we can say them, relationships, and diagrams, the last one. Okay. We also describe some of the example on things, on relationships, and also diagrams. That's all for introduction to UML. I'll see you inshallah in the second lesson to start drawing the class diagram.